All right, let's dive right in. We're going to talk about a challenge that is quickly moving from science fiction to a daily reality for a lot of business leaders. And that is, how do you actually secure the systems where your AI agents are supposed to be working together?
I mean, think about it. You're probably already using tools like AutoGPT or Crue. You're not just deploying a single AI anymore, you're building an entire AI workforce. They're collaborating, they're sharing information, they're meant to act like a real team. But this opens up a brand new and frankly critical question for anyone in charge. How can you be sure the members of your AI team actually trust each other? And here's why that question is so incredibly urgent. Get this. A staggering 65% of security exploits in these multi-agent systems, they don't come from some hacker on the outside. Nope. They happen through the communication between the agents that are already inside your trusted network. That is a massive, massive internal threat. And that really gets us to the heart of the problem here. All our traditional security models, the ones built to defend the perimeter from outside attacks, they just weren't designed for this. The main risk has completely shifted. It's no longer about what's trying to get in. It's about the internal chatter between your own AI agents. This right here perfectly captures that shift in thinking. It used to be that single-agent security was all about building a fortress around one AI. But now, with multi-agent security, it's all about managing trust inside the fortress walls, where every single agent could be a weak link. I love this quote from the source material because it just nails it. It's no longer about fighting off invaders at the gate. The danger is already inside, and it's moving through the very channels you built for teamwork and efficiency. The call is, quite literally, coming from inside the house. So, how does an attack like this actually play out? Well, the main weapon is something called agent-to-agent prompt injection. Basically, one of your AI team members gets compromised, and an attacker uses it to send malicious instructions, disguised as a normal task, to its colleagues. It's really the digital version of a trusted insider tricking the rest of the team. Let's just walk through a quick example. So, an attacker manages to compromise just one agent. Let's say it's a researcher agent that browses the web. That compromised agent then passes some poison data to a trusted analyst agent. Now, the analyst has no reason to doubt its teammate, right? So it just uses that bad data, bakes it right into its report, and suddenly your business is making a critical decision based on completely flawed intelligence. A single tiny entry point just cascaded into a major system failure. But here's the thing. It's not just about malicious attacks. There's a second, much quieter risk where the system just undermines itself. We're talking about simple coordination failures. And these aren't just little tech glitches. They are serious security vulnerabilities that can bring your whole operation to a screeching halt. So first up, you've got the infinite loop. Just picture two agents that are designed to refine each other's work. Without a clear endpoint, they could get stuck in this endless cycle of feedback, just debating back and forth forever. All the while, they're burning through your expensive compute resources and never actually finishing the job. Your productivity just hit zero while your costs are going through the roof. And then you've got deadlock. This is a classic problem where the entire process just freezes solid. You've got Agent A waiting for data from Agent B, but Agent B won't send it until it gets approval from Agent A, and nothing moves. If this happens in a critical business process, it's a total showstopper. And here's the crucial thing to understand. The health of your entire AI workforce can be totally wrecked by just a handful of faulty agents. This goes back to a classic computer science idea. How can you trust a system when you know some of its parts might be unreliable or even lying? It turns out there's a very real tipping point where the whole system just can't be trusted anymore. And this visualizes that principle perfectly. A multi-agent system can usually handle a few bad apples. It can stay stable if less than about a third of its agents are faulty. But the moment you cross that threshold, reliability completely collapses. The faulty agents can actually outvote the healthy ones, and that can lead the entire system to make some truly catastrophic decisions. Okay, so we've laid out the risks, and they're pretty serious. Let's pivot and talk about the solution. How do you actually protect your AI workforce? Well, the answer isn't some single magic bullet. It's a strategic, layered defense that's specifically designed for this new world of internal threats. A really solid defense is built on these core ideas. It all starts with agents proving their identity to each other and checking that the messages they send are valid. It also means giving each agent the absolute bare minimum permissions it needs to do its job and nothing more. That way you can isolate them, limit the blast radius if one gets compromised, and create a really clear hierarchy of trust. Now, I know that might sound a little overwhelming, but the good news is you can start making a huge difference right away just by focusing on 3 key areas. This is the practical stuff you can take back to your team like today. Okay, your first and honestly most important priority is this. You have to validate all communication between your agents. You simply cannot assume that a message from an internal agent is trustworthy anymore. Every single message has to be checked and verified, just like you would with any input from the outside world. And here is a fantastic quick win. By just enforcing a strict, defined structure for how your agents talk to each other, it's called a schema, you can block the vast majority of those dangerous prompt injection attacks. It's simple. If a message doesn't fit the expected format, it gets thrown out, period. It's a really straightforward technical fix with a massive security payoff. Second, you've got to establish clear trust tiers. Not all agents are created equal, so they shouldn't all have the same power or the same access. This is all about applying that classic security principle of least privilege to your AI workforce. And here's a pretty simple way to think about it. You might have a Tier 1 supervisor agent that can see everything and even terminate other agents if they go rogue. Then you have your Tier 2 agents doing the core work, and maybe Tier 3 utility agents that only have read-only access. This kind of hierarchy drastically limits the amount of damage a single compromised agent can cause. And your third priority, and this one is absolutely non-negotiable, is to make sure you have a kill switch. Because when all else fails, a human being has to be able to step in and shut the entire system down immediately. Look, this isn't about not trusting the technology. It's just about responsible oversight. For any complex automated system, especially one that can develop unexpected behaviors, manual overrides and kill switches are your ultimate safety net. You have to maintain ultimate human control always. So, let's just quickly recap the big points from all this. First, remember that every single agent in your system is a potential way in for an attacker. Second, those coordination failures, like deadlocks and infinite loops, they aren't just operational headaches, they are true security vulnerabilities. And finally, your best strategy is a layered defense that focuses on communication validation, tiered trust, and absolute human oversight. So we'll leave you with this question to think about. As you rely more and more on these incredibly powerful multi-agent systems, you really have to decide, are you building a strategic asset that's going to launch your business forward, or are you accidentally creating your next huge systemic risk? The difference between those two outcomes really comes down to the security strategy you put in place starting today.